Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube.
Good morning. Today I am discussing about steam condenser. A steam condenser is a device or an appliance in which steam condenses and heat released by steam is absorbed by water. It serves the following purposes. It maintains a very low back pressure on the exhaust side of the piston of the steam engine or turbine. Consequently, the steam expands to a greater extent, which results in an increase in available heat energy for converting into mechanical work. The shaded area shows the increase in work obtained by fitting a condenser to a non-condensing engine. The thermal efficiency of a condensing unit here, therefore, is higher than that of non-condensing unit for the same available steam. It supplies to the boiler pure and hot feed water as the condensed steam which is discharged from the condenser and collected in a hot well can be used as feed water for the boiler. So this is the pressure versus volume diagram. Atmospheric line, condensing, another one is the non-condensing, and this is the one is the 1 2 pressure remains constant but the volume increasing, and 2 3 looks like a PV to the power gamma is equal to constant polytropic process 2 3. Okay, PV to the power n curvilinear. The nature of the curve is curvilinear, and 3 4 that is the constant volume or isochoric process, and 4 to 5 that is the same constant pressure or isobaric, and 5 to 1 so that is the isochoric, volume is constant. And always remember the work done in isochoric process that is equal to 0. Okay, actually area under the curve, there is no area under the isochoric process. Now vacuum is a sub-atmospheric pressure. It is measured as the pressure depression below atmospheric. The condensation of steam is a closed vessel produces a partial vacuum by reason of the great reduction in the volume of the low pressure steam or vapor. The back pressure in steam engine or steam turbine can be lowered from 0.013 to 0.2 bar or even less, since the steam engines are intermittent flow machines as such cannot take the advantage of a very low vacuum. Therefore, for most steam engines, the exhaust pressure about 0.2 to 0.28 bar absolutely. On the other hand, in steam turbine, which are continuous for flow machine, the back pressure may be about 0.025 bar absolutely. Organs of a steam condensing plant. A steam condensing plant mainly consists of the following organs or elements: condenser to condense the steam, supply of cooling or injection water, wet air pump to remove the condensed steam, the air and uncondensed water vapor. and gases from the condenser separate pumps may be used to deal with air and condensate. Hot oil where condensate can be discharged and from which the boiler feed water is taken. Arrangement for recooling the cooling water in case of surface condenser is employed. Classification of condenser. Mainly condenser are of two types. One is the jet condenser, another one is the surface condenser. Actually, the function of condenser which condenses the steam. Okay. So, classification of condenser. Actually, there are two types condenser, jet and surface. In jet condensers, the exhaust steam and water come in direct contact with each other, and temperature of the condensate is the same as that of the cooling water leaving the condenser. The cooling water is usually sprayed into exhaust steam to cause rapid condensation. In surface condenser, the exhaust steam and water do not come into direct contact. The steam passes over the outer surface of turbine tubes through which supply of cooling water is maintained. There may be single pass or double pass. In a single pass condensers, the water flow in one direction only through all the tubes, while in two pass condenser the water flows in one direction through the tubes and returns through the remainder. A jet condenser is simpler and cheaper than a surface of condenser. It should be installed when the cooling water is cheaply and easily made suitable for boiler feed or when a cheap source of boiler and feed water is available. A surface condenser is most commonly used because the condensate obtained is not thrown as waste but returned to the boiler. Jet condenser. These condenser may be classified as parallel flow type, counter flow type, and ejector type. Parallel flow and counter flow condenser are further subdivided into two types, low level type and high level type. In parallel flow type condenser, both the exhaust steam and cooling water find their entry at the top of the condenser and then flow downwards, and condensate and water are finally collected at the bottom. In counter flow type, the steam and cooling water enters the condenser from opposite direction. Generally, the exhaust steam travels in upward direction and meet the cooling water which flow downward. Okay, so in counter flow type, the steam and cooling water enter the condenser and from opposite direction. Generally, the exhaust steam travels in upward direction and meets the cooling water which flow downward. Surface condenser. Most condensers are generally classified on the direction of flow condensate, the arrangement of the turbine, and the position of the condensate extraction pump. The following is the main classification of surface condenser: down flow type, central flow type, regenerative type, inverted flow type, and evaporative type. Jet condenser and surface condenser. Low manufacturing cost. Difference. Comparison between jet condenser and surface condenser. Low manufacturing cost. Surface condenser high manufacturing cost. lower upkeep, higher upkeep, required small floor space and required large floor space. The condensate cannot be used as feed water in the boilers unless the cooling water is free from impurities. Condensate can be reused as feed water as it does not mix with the cooling water. More auxiliary power required, less auxiliary power required. Feed water treatment for steam power plants. Water is one of the most important raw material. In most of the cases, water used for steam power plants contain impurities which must be treated before use. All natural water, even rain, snow, hail, treated municipal supply water, okay, contain impurities in one form or the other. Classification of impurities in water. The impurities in water may be classified as follows: visible impurities, microbiological growth, presence of microorganism is always undesirable as they may be produce clogging troubles. Turbidity and sediments. Turbidity is the suspended insoluble matter, whereas sediments are the coarse particles which settle down in stationary water. Both are objectionable. The microbiological growth, another one is the turbidity and sediments. Turbidity is the suspended insoluble matter, whereas sediments are the coarse particle which settle down in stationary water. Both are objectionable. Dissolved gases: carbon dioxide, oxygen, nitrogen, methane, hydrogen sulfide, etc. Mineral and salts: iron and manganese, sodium and potassium salt, fluorides and silica. Mineral acid: their presence in water is always undesirable as it may result in the chemical reaction with the boiler material. Presence of these salts is known as hardness. Trouble caused by impurities in water. The impurities in water may cause one or more of the following troubles. First one, scale formation. Second one, corrosion. Third one, carryover. Fourth one, embrittlement. তাহলে scale formation, corrosion, carryover and embrittlement. Methods of feed water treatment. The different treatment adopted to remove the various impurities are enumerated below. Mechanical treatment. First one is the sedimentation, coagulation, filtration, interior painting. Thermal treatment: desaeration, distillation by evaporator. And another one is the chemical treatment: cold lime soda softening process, hot lime soda softening process, and lime phosphate softening process. Ion exchange process, which may be sodium zeolite process or hydrogen zeolite process. Demineralization: blowdown under blowdown hot lime soda and hot zeolite process. Adding acid to control alkalinity and vice versa. What are the advantages and disadvantages of steam power plant? Advantages: they can respond to rapidly changing loads without difficulty. A portion of the steam generated can be used as a process of steam in different industries. can be located very conveniently near the load center. As these plants can be set up near the industry, transmission costs are reduced. Steam engine and turbine can work under 25% of overload continuously. Fuel used is cheaper. Less space required in comparison with that for hydroelectric plants. Cheaper in initial cost in comparison with that of diesel power station. So these are the advantages. Another one point, that is the disadvantages of maintenance and operating cost are high. That is the first major disadvantage. The cost of plant increases with increase in temperature and pressure. Long time required for erection and putting into action. Okay, long time required for erection and putting into action. A large quantity of water is required. Okay, large quantity of water is required. Great difficulty experienced in coal handling. The plant efficiency decreases rapidly below about 75% load. Presence of trouble due to smoke and heat in the plant. Actually, miscellaneous useful life steam power plant component. Approximately useful life sum of the components of a steam power plant is given below. Actually, component water tube boiler approximately life 20 years. Coal ash machinery 10 to 20. Steam turbine 15 to 20. Steam condenser 20. Turbo generator 10 to 20. Feed water heater, that is the 30, and pump, that is the 15 to 20. Okay, transformer 15 to 20, motors 20, air compressor 20 to 25, building, that is the 50. And steam power plant pumps. The pump used in steam power plant are classified as follows. First one is the reciprocating pump, direct acting. Second one is the power. Second one is the rotary, vane, gear, screw, lobe, centrifugal pump, volute, diffuser, axial and mixed flow. The above mentioned pumps are used for the following services: boiler feed, circulating water, evaporator feed, condensate, well water, ash slicing, fuel oil. Cost of steam power plant. A typical subdivision investment cost of steam power station is as follows: building investment cost 25%, boiler 18%, turbo generator condenser 25%, fuel handling 6%, switch yard, switching and wiring, piping 5% and miscellaneous 5%. The first one is the site: steam power plant located near load center, but other factors, water supply, land cost, transportation facility, are to be kept in view. Hydroelectric power plants, the site should be such that sufficient area, huge quantity of water at a sufficient head, cheap and rocky land and transportation facility should be available. Can be installed anywhere, and it is located at the load center. Okay, So this is the types. Another one is the initial cost. Initial cost হচ্ছে low compared to hydroelectric and atomic power plants. Initial cost minimum, that is the minimum. Another one is the fuel transportation cost and operating cost. Fuel transportation cost nil, as no fuel is required. Operating cost practically nil, since no fuel is required. Another one is the maintenance cost. Maintenance cost comparatively low. And these are the limit source of power. Source power of water in case of hydroelectric plant is not dependable because it depends upon the rainfall. Transmission and distribution cost very high because long transmission lines are required. Transmission cost is nil and distribution cost is also very small. Okay, these are the difference. Okay, প্রথমে steam power plant, hydroelectric power plant, diesel power plant and nuclear power plant. Okay. Oh.
Last, if you like my video, you have to subscribe. Okay, thank you.